All right, folks, listen up, please. A lot of questions going on about the mock, and some kids are telling me we already took the mock, and I think I explained this to you when you took the mock, but I'll explain it again. If you didn't know already, y'all are special, right? Because you guys are taking Algebra 1. So when the 8th graders took their mock, we didn't know what to do with 95 plus special children, so you guys took a practice mock. And then when they take their real test, you guys are going to take a real mock, and then eventually you'll take your real test. So you guys actually get 2 chances to make sure you're ready for this test. So yes, you have a mock coming up next week. Question, yes. I'm not sure. They change it from year to year. It just depends. Question? Well, that was 7th grade, folks. It's not the same thing. Y'all didn't have as much overlapping time with the 8th graders. Okay, so basically my advice is, folks, listen, get over it. Yes, it's a good thing. You need more practice. Now, let me talk to you about the mock and the real test. We're pretty much about a month away from your real test. You guys take your test on May 8th. But no, we have not learned everything. We've still got several little topics to learn. Now, this is what I usually save April for the random little onesie-twosie topics, I call them, where they might have 1 or 2 questions. Now, we have about 5 random topics, so if they have 1 or 2 questions on 5 random topics, that could be up to 10 questions on the real test. So we do have to go over this stuff. The main focus of Algebra 1 is linear functions, quadratic functions. If you guys understand those, that will get you through the test for sure. There's some other stuff we still have to cover. There is systems. There'll be probably 2 or 3 systems of equations. That's what we're kind of in the middle of. Mm-hmm. Okay, now, so what we're going to do through the month of April, are y'all listening? We're going to be covering those little random 1 and 2 question topics. And Colton, we're going to be reviewing what you should already know because it's over everything from August on, and there's a lot of stuff we've done, a lot of stuff kids maybe have forgotten, like domain and range, like finding zeros, finding intercepts, finding all kinds of stuff. Question? Yes, we still have to learn some new things in the middle of all that reviewing. We still have a few new things to learn. Not like humongous things, no. Again, the things I spent the most time on were linear functions and quadratic functions. That's the bulk of the test. And systems. Okay. Let's review. This is what you should already know. Look at number 1, domain and range. I still have kids who are getting these backwards. And to me, these are the ones you don't want to miss, folks. These are the ones, you got to get all those easy ones so that the ones that are a little tougher, you have a little more leeway there. But you don't want to pass up the easy ones. Domain and range of a function from a picture is easy. Domain is the x values. On this picture, there is no way you could list every x value for me because there's billions of them. There's all kinds of fractions and decimals. There's billions of points on this. I happen to have highlighted some of the important points for you just so you could see them easier. I can't list all the x values. I can, however, tell what the smallest x value is and what the biggest x value is, and all the other x values have to be somewhere in between. So this would look like, that's the domain. All right, follow-up question. Good question. What if there was arrows here? What would the domain be? All real numbers. On a regular parabola, are y'all listening? Zoe, on a regular parabola, the domain is all real numbers. This isn't a regular parabola because it had endpoints. But on a random old parabola, domain is always all real numbers. This one, though, they decided to chop off right there. Range. Range of a parabola is never all real numbers. Range of a parabola, no matter if it's a normal parabola or one that's been chopped off, it's never all real numbers. Range of this guy. Range is the top and the bottom because range is y values. Y values control the top and the bottom. What's the lowest y value? -1. Both of these points have a y value of -1. What's the highest y value? 5. So the range of this guy would go from -1 all the way to +5. Now, let's put arrows on it. That definitely changes the range too. It does not change the range to all real numbers though. It takes off the -1 part because now it's not stopping at -1. It's going down forever, but it still has a highest value. Y is less than or equal to 5. All right, number 2, calculator question. Again, you cannot afford to miss the easy ones, folks. The calculator can do this one completely for you. What am I giving you here, an x or a y? An x. They want you to take that function. When the x value is 12, what's the y value that is right across from it? What was it? It should have been -24. You could have found that in your t-chart, right? Y'all remember how to do this? You put the function rule into y equals. You go to your t-chart across from 12. Are we good with that one? Please stop me if you're not. All right, now number 3. First period struggled with number 3. How do y'all feel about this one? It is kind of, it can be turned into a zeros question. You can leave it like that. You can convert it to a zeros problem. But I'm not giving you an x value here. I'm giving you a y value. So we could leave this as it is, and we're not finding the zeros. We're finding the 8s. Or you could modify it a little bit by moving this 8 over, by subtracting 8 from both sides, and then you're finding the zeros. Either way, you're going to get the same answer. Usually, I just leave it like it is. I left it like this. So I went to y equals and I put in 2 parentheses x plus 4 squared. Then on the next row I put in an 8. And I'm going to see where these two things do what? Intersect, and it happens twice. Second function, calculate intersection, first curve, second curve, guess. -6. When x is -6, see what the y value is when x is -6? 8. Then I'm going to, I got to scroll over here to this one. How do I get over here? Trace and scroll on over there and then do it again. Second function, calculate intersection, first curve, second curve, guess. And the other time that it happens is at -2. Those are the two x values that make that equal 8. Now, you will also have, on most of your items, most of your questions will be multiple choice. So even if you had no idea how to solve this, but you've got a bunch of answers to choose from, you could have just plugged them in and checked. What's -6 plus 4? -2 squared is +4, and 2 times 4 is 8. Put a -2 in there. -2 plus 4 is 2. 2 squared is 4, and 2 times 4 is also 8. Those are the two answers that make that equal 8. Okay, number 4. I had about half of my kids in first period did it by calculator, and about half of them did it by hand. If I were you on the day of the real deal, I would probably do it both ways. It's not hard to do this one just with your brain and your pencil and paper, though. What am I giving you here? The x. This is in standard form. Standard form does have some uses. It's easy to find intercepts in standard form, and it's not that hard to do a problem like this. Where would I put this 12? For x. Instead of 3 times x, what's 3 times 12? 36 plus 2y equals 12. This is not a hard equation to solve. Subtract 36 from both sides, you get a -24 over here, and the answer should be -12. Did anybody do it that way? Guys, I have a feeling, Colton, some of y'all are not paying attention to this review. I promise you, I give you review problems that are going to be like your end of course exam. And this mock test that you're taking, it's going to be a major grade. You could also change it to slope-intercept by moving the 3x to the other side. Some kids aren't that great at doing this, so that's why I would maybe suggest you do it 2 different ways. You got to move that 3x over, it becomes -3x. Divide everything by 2, and then put that into y equals. Go across from a 12 and see what the answer is. Is that what y'all did? Did you get the same thing I got? Okay. I'm going to modify this question a little bit. Pretend like this wasn't here at all. I'm giving you a linear function in standard form. I'm adding a problem here. I need y'all to pay attention. I want you to find the 0. You can find the 0 without changing it to slope-intercept form. Okay, when I'm asking you to find the 0, that's one of the intercepts I want you to find. What intercept is that? What's another word for a 0 of a function? It's not the y-intercept, no. X-intercept, 0, roots, all those mean the same thing. Anytime you want to find an x-intercept, a root, a 0, that means that's when the y value is 0. It's super easy to put a 0 in for y here. What's 2 times 0? Look at that easy equation. 4. 4 is the root. That means this thing crosses the x-axis at 4. What if I wanted the y-intercept? A root is not a y-intercept. What if I wanted the y-intercept? It's not 12. If I want a y-intercept on any function, I put a 0 in for x. What's the y-intercept? 6. So this thing crosses the y-axis at 6. Could you have converted it? Absolutely. Some kids want to do it in the calculator. That's fine too. You would have had to, again, just like we did a second ago, move the 3x over, divide by 2. You could have put that in your calculator. Obviously, look, the y-intercept sure was 6. And then you could put in y equals 0 to find the x-intercept, and it should come out to be 4. Are we good with that? Okay, do y'all remember, these? I think there's going to be one of these on there. Try that one real quick, because you will have one like that. Pasadena ISD, you know, they make their own mock. Just FYI. For what? Well, that's because that's a harder one to make up. The mock last year was not just the one from the previous year. They added, I mean, they might have used some of the questions, but they also added stuff. Yeah, well, that's because I... Alright, the square root of 80. We're looking for perfect squares that are hiding in there. Y'all remember this little birthday cake or wedding cake thing? Or the factor tree. I found a pair of 2's, which is a 4. I found another pair of 2's, which is another 4. And then what's 4 times 4? I usually put all the square roots I find, I put them back together to make the biggest square root that I can find. And the square root of 16 is, and what had to stay inside. And again, on these, one thing you could do, you could check to see that this and this are equivalent. That's at least one thing you could do. The one thing I'm afraid they might try to trick you with is put the answer like this, 2 times the square root of 20. Which technically this and this are the same thing, but this is not reduced all the way. There's still a perfect square hiding in there. Okay, so they just didn't reduce that one all the way. But one thing you can at least do is make sure that this and this have the same value. So let's check that out. I'm going to find the square root of 80. And I'm going to leave it on my calculator screen. And then I'm going to do 4 times the square root of 5. And I do get the same value. And 2 times the square root of 20 will give you the same thing as well. So I don't want you to use this just to find the answer, because the thing that's wrong with 2 times the square root of 20 is there's still a 4 hiding in there that you should have taken out. Yeah, that one would be considered not all the way reduced. Well, they try to do all kinds of things to make you to distract you from the right answer. Okay, and so we're going to keep reviewing. Now listen up, I want to tell you something else, folks, about your real test. Your real test is May 8th. Okay, and we are pretty much on our last 6 weeks. I know the 6 weeks doesn't end until this Friday, But then we're starting our very last grading period. Listen up to what Miss Barber allows me to do every year. Now, there's a couple of things this depends on. Usually I get your scores the last week of school. Okay, and grades are sometimes due like pretty early in that last week of school. But this is what Miss Barber has allowed me to do, and y'all are going to want to pay attention. I'm not worried about anybody in here not passing. I mean, you do have to pass the end-of-course exam to get credit. I have never had a student who didn't pass the end-of-course exam. Okay, so I'm not worried that you're not going to pass. We want to be commended, not just pass, right? Now, listen. Whatever score you make on your end-of-course exam, if it's higher than your current average, Miss Barber has let me allow your end-of-course score to be your entire 6 weeks average. So let's say you have a 82 in my class for the 6 weeks, and then you make a 95 on the EOC, that becomes your whole 6 weeks grade. Now, if it's higher. Now, it will still, listen, it will still count. So let's say you have 100 in my class, and then you make a 65 on the EOC, I'm still going to count it. It's still going to be, you're not going to have 100 anymore. Now, that's not going to happen, but I'm just giving you a for instance. So it has to count as part of your grade, and hopefully it will be a grade raiser for all of you. That's your incentive to make sure that you study and are really ready for this thing. And you're really paying attention this last 6 weeks. Yeah, before it's said and done, folks, some of the practice we're going to be doing this next few weeks, I've got all those, remember all those little quizzes I have? I've got a ton of those from all of the last few end-of-course exams. And that's going to become your homeworks and your little quizzes and all that stuff. So by the time it's all said and done, you probably will have done 4 end-of-course exams. So you should be well prepared, yes. On the real thing, there's usually about 60-something questions. No, the Math Algebra Star is the EOC. It's called Algebra 1 End of Course Exam Stars, blah, blah, blah. This is the first time we've had... This is the first time that class has ever had... We've never had algebra kids in Connect yet. No. Alright, folks, we got stuff to do still. Go ahead and get your homework graded, page 351 and 352. Quickly get that graded so we can move on. I got a little bit of a new thing to show you. Folks, we are moving into our last 6 weeks. That whole little speech was supposed to make you focused and really want to do your best, not be silly. I'm okay with that. That's a risk I'm willing to take. Do I always have the highest scores? Well, let me explain to you about, it's kind of like really not fair how we compare our school to other schools. Because I have 95 algebra kids, and usually Southmore is first, but they have about 40 algebra kids. And yes, our school is bigger, but not that much bigger. So most intermediates do not put as many kids in algebra as BHI does. So Southmore, yes, usually gets first place. We're usually right there with them. And we have more kids, so I kind of feel like it's not really a fair comparison. Bondi is another one. It's usually Bondi, Southmore, and BHI contesting for first place. Now Thompson, which is most like us and also has about as many kids as us, we usually, not to brag, but we usually blow Thompson out of the water. No, she doesn't. No, it's because you guys are just brilliant. Alright, these are 8 points each. It's one huge grade. It's not 2 separate grades, 8 points apiece. Now, if you didn't do well on this, guys, we still haven't taken a test over systems of equations. Make sure you understand these. If you're not doing well, let's talk about it. Number 3 on 352. Yeah, I need all of y'all paying attention to number 3 on page 352, because I have a feeling the way you got the answer is probably not how the algebra gods intended. I'm about to change screens. I need y'all's focus and attention. Trajan, do you need to go back to your... Yeah. I know, but I thought you could handle it, but I'm thinking maybe you were right and I should have let you go back to your little... Yeah, corner. I couldn't think of the word. Thank you. Okay, can I change screens? Everybody, hush please. Look at number 3 on page 352. Now, I am afraid what they might do, because the end of course exam has gotten more difficult than this worksheet right here. They have progressed with their level of difficulty. They could give you a question like this, and I want to make sure you can work it out algebraically. It said the width is 3 feet longer than the height. They've got a width and a height. Same thing as width and length. It doesn't really matter. Width is 3 feet longer than height. That means height is x and width is x plus 3. Are you with me there? Now, we are used to doing perimeter problems. Okay, they usually do like to put a perimeter problem on there. This, however, was not a perimeter problem. It was an area problem, which is different. They said the area of this cabinet, the front of this cabinet, is 18. Well, you don't find area by adding up all 4 sides. How do you find area? By multiplying, which turns this into a completely different kind of equation. It turns it into a quadratic equation. Now, it's not that hard to solve this. What do I do with that 18? Move it over, set it equal to 0. I'm going to factor this. This was easy factoring. Factors of 18 that add up to 3. I need a positive 3 and a negative 18. I'm going to get 2 different answers for x. Well, I can't have 2 different heights. Which one of these can't be a height? Yeah, you can't have a negative 6 height. That means the answer to the equation is 3. The height is 3. Well, the width was 3 more than that, so what's the width? 6. Does that give you an area of 18? 3 times 6 is 18. Is one 3 more than the other? Yes. So, yeah, we really hadn't practiced any like that. And who knows, they always find a way to surprise me, guys. Always. Every year there's a surprise. Not till after. Like, next year when y'all are at Dobie and I finally can look at the test, I'll be like, oh, wow. Yes. No, because most of them are okay, but they always come up with a new way to ask questions. It's all one grade, just kind of fold it over. All right, now pass those up. Let's move on to one little new topic. Your homework should always be in your folder. Why would you ever go, I'm going to take this homework out and leave it in my room? It was just taking up too much room in your binder, you couldn't handle it? Bet you're wishing you'd turn that light off right about now. Alright, standard form. We've done this a whole bunch, guys. ax squared plus bx plus c. That's standard form. Y equals. Guys, I cannot talk over you, and this should be the 6 weeks above all other 6 weeks is that you are focused, laser beam focused, and really paying attention. I am. No, you're not. Every time I look at you, you're turned around being silly. Now, this is kind of new to me. I'm not going to lie. This is not something I have taught. This is something they just recently started putting into Algebra 1, and that's vertex form of a quadratic function. Remember, a quadratic function is when you've got an x squared, when x squared is your highest, and it makes a parabola that either opens up or down. That's what quadratics are, right? They're not linear. They're quadratic. They're called parabolas. Just like linear functions, think of all the ways we can write a linear function. Slope-intercept form, standard form, point-slope form. Well, there's also another form for parabolas. This is the way we have done them all year. Now I'm going to introduce you to a new form. It's called the vertex form. Are you ready? On your formula chart, they use f of x instead of y. Let me show you how it looks on your formula chart. But if you don't like f of x, what can you put in its place? Y. F of x equals a parentheses x minus h parentheses squared plus k. That's vertex form. Okay, just write it down. Do you have to memorize that? No. That will be on your formula chart. Now, you're going to have to do some stuff with it. What they want you to do with it, who knows? I can show you some of the stuff I've seen that they want you to do. Today, we're just going to practice writing it and maybe converting it. I do want to show you that. I'm not sure if they would ask you to, but just in case, I want us to be ready. But if you're asked to compute with something in vertex form, your calculator can do that. Most of the time, you don't have to convert it unless they specifically ask you to. Now, let's look at this vertex form. One thing they don't tell you on the formula chart that you have to know, vertex form obviously has the what in it? The vertex. This is the part they don't tell you. The letters that stand for the vertex are H and K. So when you're looking at an equation that's in vertex form, H and K are going to actually be numbers. A will be a number. The only thing that's going to be the letters are the x and the f of x, the x and the y. Vertex is the highest or lowest. It's either the minimum or the maximum. So what's one of the benefits of vertex form? You can see what the vertex is just by looking at it. Okay, for example, I'm going to show you. That's in vertex form right there. Are you with me? Well, it just depends. They might give you a problem that's in vertex form and ask you to find the zeros, or ask you to find a certain x value, or now what is the vertex of this? It's not negative 5, 8. It's no. Okay, but it's 5, 8. It's 5, 8. It's x minus whatever h is. Well, the x and the minus are always there. So that's just your x value right there. So the vertex here is 5, 8. Are you with me? Okay, we're going to talk about that. Right now, I just wanted you to see what it looks like when it's in vertex form. We had one on your warm-up that was kind of in vertex form a second ago. Remember that? Let's go back to the warm-up. So sometimes they don't even tell you, hey, this is vertex form. But this is vertex form, and they set it equal to 8. It's not really in vertex form. You'd have to move the 8 over. But it's kind of like a modified vertex form. Can that be a plus? See what I'm saying? No, can the 8 be a plus? Not if you have to move it over. So the vertex of this would have been 4, negative 8. Oh, negative 4, negative 8. You're right, negative 4, negative 8. The x would be the opposite, yes. Okay, now what else am I going to ask you to do? Well, let's just see. Again, today I'm just kind of introducing this. Today I just want you to understand there is a different form that you can use. Okay, here is an equation, a quadratic equation. How can I tell it's quadratic? It's got an exponent of 2. What form is it in? Vertex form. Could you tell me the vertex just by looking up here? 6, 8. Now, I just want you to be prepared. They might ask you to convert this. I am telling you right now, if they want to know anything else about this, I would just leave it exactly like this and plug it into my calculator like this. But just in case, because they always find a way to surprise me, what if they want you to convert it to standard form? And I want to be sure we can do that. Which this is good algebra practice anyway. Okay, you do have to distribute the 2, but you cannot do that first. Exponents come before multiplying. Exponents are stronger. So I have got to do x minus 6 squared first. And that's a little tricky. You cannot do that in your head. You've got to do FOIL. Remember FOIL? How do you square a binomial? You've got to write the binomial side by side and actually multiply it out. So I'm going to just hold on to that 2 for a second. And I'm going to rewrite x minus 6 squared as x minus 6 times x minus 6. That will remind me that that's not... I mean, there is a way you can do it in your head, but most kids mess it up. I would just FOIL that thing. So that's going to be x times x, which is x squared. Then what? Minus 6x. Then another minus 6x. Then a plus 36. X squared minus 12x plus 36. And remember there was a 2 out in front and a plus 8 on the end. Okay, so I took care of the squaring. What else do I do? Now I take care of the multiplying, the doubling. So that's 2x squared minus 24x plus 72. And then don't forget that plus 8. And now we're almost done. 2x squared, y equals 2x squared, minus 24x plus 80. Now this and this represent the same function. However, there's even something else they might do. What do you know about all of these? What do you notice about them? They can be reduced. So yet another version of this would be y equals x squared minus 12x plus 40. That is standard. This is standard. Yeah. This is how we're used to seeing it. This is just a different version of it. Look how different they look, but they're the same parabola. Would they want you to convert it back? Ooh, I don't know. I'll have to look into that. I don't think so. All right, try this one, please. Y equals negative 2 parentheses x minus 3 minus 9. Oh, squared. That's vertex form of a parabola. Can you tell me what the vertex is? 3, negative 9. Convert it. Trajan? Okay, and I don't think this one could be reduced. Did y'all get what I got? Y equals negative 2x squared plus 12x minus 27? Okay, when you did the FOIL, did everybody get x squared minus 6x plus 9? Negative 3 times negative 3 is a plus 9. Then, it's minus 6x, isn't it? It's x squared minus 6x plus 9. Then distribute the negative 2, and you get negative 2x squared plus 12x minus 18. And then don't forget there was a minus 9 outside the parentheses. So a negative 18 and a negative 9 make negative 27. You want to try one more? Y'all are so weird. What's the vertex? 1, negative 10. The homework was 351, 352. 1 through 6. I think so, yes. 1 through 6 on both of those pages. Okay, question. I have some kids who don't understand how I'm squaring x minus 1. Squaring has to come before multiplying, so I cannot distribute the negative 3. So I'm just going to come over here to the side and do x minus 1 squared. Some kids think they can do this in their head, and they give me something like this, x squared plus 1. They square that and square that. That is not correct. The only way you can square a binomial is by foiling it. X minus 1 squared literally means x minus 1 times itself. So I rewrote this as x minus 1 times x minus 1. The negative 3 is still there. The minus 10 is still there. But that's how you square a binomial. You've got to do this FOIL business. First terms, outside terms, inside terms, you end up and last terms. You end up multiplying. You get 4 little products here. Here's my first terms, x times x. Here's my outside terms, x times negative 1. Here's my inside terms, another negative 1 times x. And here's my last terms, negative 1 times negative 1 is positive 1. See how I get 4 little products here? First, outside, inside, last. That's x squared minus 2x plus 1. So it took all of that work just to do the squaring of the binomial part. Now I can finally distribute the negative 3 and then combine it with that negative 10. Did y'all get this when you squared the binomial? Do you want me to tell you the shortcut? Here's the shortcut to squaring a binomial. This does get squared and this does get squared. X squared is x squared. Negative 1 squared is 1. It's the middle term that you've got to know how to do. The way you get the middle term is you go ahead and multiply these two things together and double it. What's negative 1 times x? Negative 1x. Double that and you get negative 2x. Times it by 2. When in doubt, folks, I would just FOIL it out. When in doubt, FOIL it out. Okay, now distribute the negative 3. I get negative 3x squared plus 6x minus 3, and I've still got that minus 10 on the end. So I got negative 3x squared plus 6x minus 13. So yeah, it takes a little bit of work to convert. Maybe, hopefully, they won't ask you to convert. But you never know. So we'll come back to that. Now, listen, I'm not going to be here tomorrow. I am leaving you one of those little review quizzes. And you will have homework. Today, I'm giving you a homework assignment on systems of equations. I'm only going to make you do one side for homework tonight. Tomorrow, guess what? You're going to do the other side. So tonight, you're doing 5-2. Bring it with you because tomorrow, you're going to do, I think it's 5-3 side. I'm about to hand it to you. Okay, so this is your homework for tonight and tomorrow night. And tomorrow in class, you'll do some kind of little quiz. And when you're done, you work on the homework. It's not a page. It's a worksheet I'm about to pass out to you. I'm about to give this to you guys. You don't have it yet. I'm going to give it to you.